Hi guys, hello, Mr. Thompson again, this time with part 2 of Lesson 5, Session 2 in the Ready textbook. That's page 91 and 92. We're going over those green practice pages. So let's look at the practice on page 91, solving multi-step ratio problems. So let's look at this example. Jasmine is making a spray cleaner. She mixes 1.5 cups of water, a 1/4 cup of white vinegar, and a 1/4 cup of rubbing alcohol. How much white vinegar would Jasmine need to make 5 cups of the spray cleaner? So we have to pull aside some data in order to figure this out. It's not quite on the surface, is it? So to find out how much she would need to make 5 cups, first we need to know how much spray cleaner she makes with all of her ingredients, right? And to do that, we have to pull those numbers that we have: 1/2 cup of water, a 1/4 cup of vinegar, and a 1/4 cup of rubbing alcohol. If you add those together, you find out that she makes 2 cups of cleaner with those ingredients. So how much white vinegar, the question is asking, how much white vinegar would she need to make 5 cups? So we know how much white vinegar she needs to make 2 cups. She needs 1/4 cup of white vinegar to make 2 cups of cleaner. So we want to know how much vinegar for 5 cups of cleaner. So what we can do is we can make a proportion, right? Like it says in this example. For every 2 cups of cleaner, she needs a 1/4 cup of white vinegar. That's what we just saw. So for 1 cup, she would need 1/4 divided by 2, right? Because we're looking at vinegar per spray cleaner. So we want to find the unit rate for that. So to find vinegar for 1 cup of spray cleaner, you divide. 1/4 divided by 2 is 1/4 times 2/1, which gives you 1/8 of a cup of white vinegar. So then find out how much white vinegar she'd need. Since it's 1/8 cup per 1 cup of cleaner, she wants to make 5 cups of cleaner, so 5 times 1/8 gives you 5/8. So she would need 5/8 cups of vinegar. So A, in the example, what is the constant of proportionality for cups of vinegar to cups of spray cleaner? And that would be what? That would be the 1/8, right? So what is the constant of proportionality? That constant of proportionality is 1/8. Because it's 1 cup of vinegar to 8 cups of spray cleaner, so it's 1/8 cup of vinegar to 1 cup of spray cleaner. So Jasmine is making more spray cleaner, but this time she only wants to use 1 cup of water. So how much spray cleaner will she make if she uses 1 cup of water? And show your work, of course. So I'm going to pause for a second. You can work that out, and when you come back, we'll check it. Okay, welcome back. So let's take a look at this now. First of all, we need to figure out what our ratios are going to be, which way that proportion is going to go. Now, she's looking for how much spray cleaner will she use per cup of water. Aha. If we're looking per cup of water, we can use that as our unit rate. So we can say how much spray cleaner per cup. So let's write that down. We need cups of cleaner per cup of water. That's how we'd set that up. So what do we have? We have how much water per cleaner? What does it say up here? We need, how much does she need? She needs 1.5 cup of water, which makes 2 cups of cleaner. So it's 1.5 to 2. But down here we're looking at cleaner per water. So how much cleaner? 2 cups. How much water? 1.5 cups. So we can take 2 divided by 1.5 to find out the unit rate. So let's do that. So 2 divided by 1.5 is 2 multiplied by 3/2, inverse of that, 2/3, 2/3. which gives you 4 over 3. And 4 over 3 is the same as 1 and 1/3. Okay, so that gives us 1 and 1/3. Have to label our responses. 1 and 1/3 of what? 1 and 1/3 of a cup of cleaner. Or a cup of, yeah, 1/3 of a cup of cleaner, because the question was asking how much cleaner can she make for 1 cup of water. She can make 1 and 1/3 cups of cleaner with 1 cup of water. So there you go. That's page 91. Let's move on to page 92 and see what we have. Question 2. Kadeem and Quinn both drive 25 miles. Kadeem drives at a constant speed of 50 miles per hour. Quinn drives at a constant speed of 75 miles per hour. Who takes longer to drive the 25 miles, and how much longer? And show your work. So let's see. So we're comparing Kadeem and Quinn. Let's look at our data. They both drive 25 miles. Now Kadeem drives at a constant speed of, here's a unit rate, 50 miles per hour. And that's Kadeem. Quinn, his speed is 75 miles per hour. So we have 2 different unit rates for 2 different speeds, 2 different constants of proportionality. So who takes longer to drive to 25 miles, and how much longer? Well, let's figure this out. Let's make a column for Kadeem. And let's make a column for Quinn. Okay, Kadeem drives 25 miles. And Quinn drives 25 miles. So far, so good. Now, his constant of proportionality, call it CP, constant of proportionality is 50 for Kadeem, because he was driving 50 miles per hour. And the constant of proportionality for Quinn is 75, because he's going 75 miles per hour. So the question is, how many hours for both? So let's figure this out. Kadeem, 25 miles at 50 miles per hour. Quinn, 25 miles at 75 miles per hour. Well, we can make a nice, tidy little equation with this, can't we? Because if we have miles per hour, that's 25 miles at 50 miles per hour. If it's 50 miles per hour, we can write miles equals 50 times the number of hours, right? Because 50 miles per hour is 50 times the hours to get to the miles. Same thing with Quinn, except his miles are 75 times the number of hours he's been out. So now we're finding miles per hour. Now we know what the miles are. Miles are 25 in both cases. So let's plug that 25 in. We can say we have 25 miles equals 50 times the number of hours. And over here, for Kadeem, we have 25 miles equals 75 times the number of hours. So all we have to do is solve for h, right? And to do that, we have to get 50 over to the other side. We can do that by dividing both sides by 50. So divide that by 50, divide that by 50. And these two 50s cancel. What's 25 over 50? That reduces down to 1/2, doesn't it? So 1/2 is the number of hours for Kadim. He's been driving for half an hour. Let's take a look at Quinn. Let's solve his equation. Now, he went 75 times the number of hours. Divide both sides by 75. Those hours cancel out. And 25 divided by 75, well, 25 goes into 75 3 times, so that's 1/3 of an hour. So, here we have our 2 bits of information. Kadim goes 1/2 of an hour. Quinn goes 1/3 of an hour. So let's answer our question. Who takes longer to drive the 25 miles? Who takes longer? Kadim takes longer, because 1/2 is greater than 1/3. So how much longer? Well, how much longer? We can figure that out, right? Because if we have 1/2 hour for Kadim minus that 1/3 of an hour for Quinn, and that is something we have to find a common denominator for. So our common denominators are 6s, aren't they? So 3/6 minus 2/6 gives you 1/6. So 1/6 what? 1/6 of an hour. So it takes them 1/6 of an hour longer to cover that distance. Now, no one looks at hours in sixths. How much is 1/6 of an hour? Well, we can figure that out too, right? Because if we have 1/6 of an hour times 60 minutes in 1 hour, that gives us 60 over 6, which reduces down to 10 over 1, which is 10 minutes. So the answer to our question, who takes longer to drive? Kadim takes longer by 10 minutes. Kadim takes 10 minutes longer. There you go. And that's what that looks like. So, let's look at number 3 now. Pilar and Ravi start at opposite ends of a 55-mile bike trail. They start riding their bikes toward each other at the same time. After 3 hours, they meet. Pilar rides 34 miles before they meet. What is Ravi's average speed? And show your work. Take some time, figure that one out, and I'll be back, and then we'll go over it. Okay, welcome back. So, this is a tough one. You gotta really pull your data out carefully, don't you? So, we know that we have a 55-mile bike trail, and they're meeting after 3 hours, and Pilar rides 34 miles. So, we know that Pilar rides 34 miles in 3 hours. But it's asking what Ravi's speed is. So we got to figure out, first of all, how far he rode. So let's think about this. Let's say, here's our road. And here's our bike. Here's our other bike. This spike is Pilar, and this spike is Ravi. And the road is 55 miles long. And Pilar goes 34 miles down that 55-mile road. So if he starts here, he's going to go there, right? Which is 34 miles in 3 hours. Okay. Now Ravi, on the other hand, he goes whatever this distance is. We don't know how far that is, but we know that he took 3 hours to do it. So, first of all, how far did he go? Well, if we went 55 miles altogether, and Pilar went 34 miles, then Ravi went 55 minus 34, right? So 55 minus 34 is what? 21. So he went 21 miles in 3 hours. Oh ho, look, we have a ratio. So 21 miles in 3 hours. What does that work out to in miles per hour? Well, 21 miles in 3 hours is the same as 21 divided by 3, and that just reduces down, doesn't it? That works down to 7. 7 what? 7 miles per 1 hour. So we have 7 miles an hour. So the answer to the question, what is Ravi's average speed? The average speed is 7 miles an hour. All right. Now we could also find Pilar's, right? We could take 34, divide that by 3, and that would be his speed in miles per hour. But notice the question is just asking for Ravi's speed. So we're just using Pilar's speed to get to Ravi's speed. Let's look down at number 4. Riley finds a recipe for a bubble solution, and it uses 1 cup of water, a 1/4 cup of dish soap, and 1 tablespoon of corn syrup. She uses 2 cups of dish soap. How much water should she use? So let's see. We need to pull our data out, right? We have, she's using 2 cups of dish soap. The recipe has a 1/4 cup of dish soap per 1 cup of water. And we're looking for how much water. Okay, so we're looking at water per soap. And a tablespoon of corn syrup. Well, that's nice to know, but that data isn't necessary for this problem, is it? So we can disregard that. So, show your work. Let me know, and I'll be back in a second. All right, welcome back. How'd you do? Well, first of all, let's be sure and set up our proportion properly, right? We're looking for how much water should she use per 2 cups of dish soap. So looking for water per soap. So we can say we have water per soap. And this says 1 cup of water per 1/4 cup of soap. So that would be 1 cup of water per 1/4 cup of soap. And from that, we can find our unit rate. That's how much water per 1 cup of soap. So 1 divided by 1/4 is the same as 1 times 4 over 1, which is 4. So that's our unit rate. So our unit rate is 4. So the constant of proportionality is 4 cups of water for 1 cup of soap. And we want to find out, if you use 2 cups of soap, how much water should she use? So we found out water per 1 cup of soap. It should be an easy thing to find the water per 2 cups of soap. So let's do that. And we'll do that let's use an equation this time. So we know that we have a relationship between water and soap. Now we know that 4 cups of water make 1 cup of soap, right? That's what this constant of proportionality tells us. 4 cups water, 1 cup of soap. So that means if 4 cups of water are 1 cup of soap, water equals 4 times the amount of soap. So our constant of proportionality goes on the soap side of things. All right, now we know how much soap she has. We're looking for water. So water equals 4 times the amount of soap she used. She used 2 cups of soap. 4 times 2 is 8. So the amount of water she uses is 8 cups. So we have 8 cups of water, and that is our solution. How much water should she use? She should use 8 cups of water. All right. Just a few problems, but they were doozies, weren't they? You have to really read those questions, pull out your data, find out what that question is actually asking you, and then be able to find your constant of proportionality and plug it right in, and just like magic, those puzzles unravel themselves and you can find the answers. So, thus ends session 2. Next time we have lesson 5, session 3. So, stay tuned and we'll get to those in just a moment. Have a great day, guys. Bye.